Hey guys, Mrs. O'Donnell here. Today's lesson is about compound probability. Let's see how this is going to go today. Okay, our goals are to determine if events are independent events, find probability of independent and dependent events, and find conditional probabilities. Okay, here you see our agenda. Again, please come to my office hours from 1 to 2 if you have questions. I'm not holding office hours on Friday, so you can't come on Friday. Okay, so what is probability? So let's recall, first of all, the probability of an event tells you how likely an event is to occur. It is the ratio of the number of successful outcomes in the event compared with the total number of outcomes in the sample space. And yesterday we learned this formula right here, that the probability of event A is, the way to find that is by taking the number of ways that event A can happen divided by the total number of outcomes in the sample space. Okay, so let's try one. A six-sided die is tossed. So let's make sure we remember what is a sample space. Anytime I ask any of these little questions, I would challenge you to quickly pause the video and just try and think for yourself. Try and recall or retrieve that information from your own brain, right? Okay, so what is a sample space? Remember that a sample space is all of the possible outcomes. So for a six-sided die, our possible outcomes are 1, 2, 3, 4, 5, and 6, right? And how many outcomes are there in the sample space? There is a total of 6 possible outcomes. So what is the probability of rolling a prime number? Well, so to answer this question, we have to remember what are our prime numbers. So our prime numbers are numbers that only divide by 1 and themselves. 1, however, is not considered prime. So that tells us that 2 is prime, 3 is prime, and 5 is prime. So what is the probability of rolling a prime number? That would be our number of ways that it can happen divided by the total number in our sample space, which is 6. And of course, we know that 3 reduces to 1/2. And since we're working with probability, we can state it as a fraction, as a decimal, or as a percent, so 50%. All right. Okay, so let's try another one. So a bag contains 4 red marbles, 2 black marbles, and 3 green marbles. 1 marble is drawn from the bag. So what is the sample space? Well, let's see here. We've got 4 red marbles. So 1, 2, 3, 4. We've got 2 black marbles. 1, 2. And we've got 3 green marbles. 1, 2, 3. That's our sample space. It's all of the possible outcomes. Okay, so how many outcomes are there in the sample space? So in order to figure out how many outcomes there are, we just count them up, right? Or 4 plus 2 plus 3, which is 9. Let's see here. Okay, so there's 9 total outcomes in the sample space. So what is the probability that a marble drawn is red? Well, we see that we've got 4 red marbles out of 9 total marbles in our sample space. So 4 out of 9. And of course, we can write that as a decimal, which is 0.44 repeating, or as a percent, which would be 44.4% rounded. Okay? All right, so next I want to talk to you guys about simple versus compound events. A simple event is an event that has just one outcome. So for example, the probability of rolling a 2 when you roll a dice, the probability of flipping a heads, the probability of rain. Those are all examples of events where you just have one possible outcome. A compound event consists of 2 or more outcomes. So for example, probability of rolling a number greater than 2, or the probability of the weather other than sunshine, right? So your numbers greater than 2 would be 3, 4, 5, and 6, or weather other than sunshine, well, that could be so many different things, right? That could be snow or rain or hail. We had hail last week, so it could be a lot of different things. And as always, our method of calculating probability has not changed, right? So to find the probability of an event, you take the number of ways that that event can happen divided by your total number of outcomes in the sample space. Okay, so the next thing I want to talk to you guys about is independent and dependent events. So when you're determining the probability of 2 events, which is sort of like a compound probability, you need to know if they are independent or dependent of one another, because it will change how you determine the probability. So if 2 events are independent, if and only if knowing one outcome has no effect on the probability of the other event. 2 events are dependent if and only if knowing one outcome has an effect on the probability of the other event. Okay, so if they're independent, the outcome has no effect. The first event has no effect on the second event. If they are dependent, then your sample space is changing from your first event to your second event. Okay, so for example, determine if the events are independent or dependent. Okay, so you flip a heads on one coin. So take a minute, pause the video, try it out, and then we'll come back together. Okay, so welcome back. If you didn't leave, that's fine too. So you flip a heads on one coin and a tails on another coin. Okay, so if you flip a heads for one coin and a tails on another coin, those are going to be an example of independent events because the coin flip of the first coin does not affect the coin flip of the second coin. Okay. Number 2, you pull a red marble out of the jar and do not replace it. Then you pull a green marble out of the same jar. Those are going to be dependent events because the number of marbles in the jar for the second pull is going to be lower by 1 from the number of marbles from the first pull. So that would change your denominator of your events. Okay. And number 3, your teacher chooses one student to lead a group and then chooses another student to lead a different group. So this one's a little tricky because it's maybe not as intuitive, but this is actually also an example of dependent events. Because after a student has been chosen to be a leader of a team, that student can't be chosen again, and your sample space of students to choose from has gone down by 1. All right, so let's talk about independent events. So 2 events are independent if and only if knowing one outcome has no effect on the probability of the other event. So listing the entire sample space to determine the probability of a compound event can be time-consuming. Knowing the right rule to use makes calculating probability much faster. So for example, if events A and B are independent, then what you would do is you would find the probability of event A first. Then you would work to find the probability of event B, making the adjustment in your sample space. And you would multiply them to find your probability of the events happening. Okay, so let's look at what that actually looks like. And you may have noticed this pattern with the events that we were working with yesterday. We were just working with the sample space, but okay. So you flip a heads on one coin and a tails on another coin. So these are independent events, right? We already know that. So if you flip a heads, right, what is the probability of flipping a heads on one coin? Well, your successes would be 1, right? You have 1 out of 2 chance of flipping heads on a coin, right? You can either flip heads or you could flip tails. So you have a 1 out of 2 total chance of flipping heads. Then, same thing with your second flip. You have a 1 out of 2 chance of flipping a heads or flipping a tails on your second flip, right? So if we multiply those, that shows us that 1 times 1 is 1, 2 times 2 is 4. So we have a 1 out of 4 chance of flipping a heads and then a tails. Okay. And if you don't believe that this rule works, test it out. Go through and write out your sample space, right? Make that tree diagram. You could flip, flipping 2 coins. You could flip a heads and a heads and a tails and a heads, or a tails and a tails, right? So we would have a 1 out of 4 chance of first flipping a heads and then flipping a tails. That's this one right here. All right. All right, so next I want to talk to you about dependent events. So 2 events are dependent if and only if knowing one outcome has an effect on the probability of the other. And we typically see this by a reduction in the sample space. So listing out the entire sample space to determine the probability is time consuming. Knowing the right rule to use makes calculating probability much faster. Okay, so if events A and B are dependent, we can use this rule here. And what this rule says is first you find the probability of event A, and then you find the probability of event B after A has happened. So you have to make adjustments to your sample space based off of what happened in event A. All right, so let's check it out. So we have this problem from our earlier page. It says there's a jar with 5 red marbles, 3 blue marbles, and 2 green marbles. Find the probability that you pull a red marble out of the jar. Do not replace it. Then you pull a green marble out of the jar. Okay. So first thing we want to do is figure out what is our probability of pulling a red marble out of the jar. So if we pull a red marble out of the jar, that would be 5 out of what's our total number of marbles. So let's see here. 5 plus 3 is 8 plus 2 is 10. So it would be 5 out of 10 chance of pulling out a red marble. Okay. Then we're going to pull out a green marble from the same jar. The problem is that we no longer have 5 red marbles because we took that out. Now we only have 4 red marbles. So what that means is instead of having 10 marbles, now we have 9 marbles in the jar. And what's the successful outcomes of pulling a green marble? Well, that's still 2 green marbles. Okay, so to find our probability here, we just multiply across. 5 times 2 is 10, and 10 times 9 is 90. So this is, the probability would be 1/9, which we know we can represent as a decimal, 0.11 repeating, or also as a percent. So 11.1% chance of pulling out a red marble and then a green marble from the jar. Let's see here. I think that's about all I've got for you on probability. Let's see what's coming on the next slide. So make sure you fill out today's Google form. I'm wondering if I updated that link. let's check the attendance. Let's check this one. So use this link for your Google form. It's also posted in Google Classroom, and come see me during office hours if you have any questions. Thanks so much. Have a great day.